Fusion Mobile, quality e-learning experience on the go.
Now the next topic is soil texture. Soil texture. Soil texture is defined as the degree of coarseness and fineness of the soil. The degree of the coarseness, I mean how rough, and fineness, how smooth of the soil. That's texture. Most often when you take sand into your hand, you can feel the texture. Maybe it is sharp, it is smooth or fine. What I'm trying to find is the texture. Now, there are different textures to different soils. So we have examples which we are going to consider. And we can also vary the texture, consider the texture based on the sizes of the particles, the grains of the soil. So based on the particles of the soil and the sizes, we have about 7 types now of the soil. 1, 2, 3, 4, 5, 6, 7. Stone, gravel, fine gravel, coarse sand, fine sand, silt, and clay. These are the universal soil. But when we talk about agricultural soil, we will limit it only to sand. Agricultural soil will limit to sand, fine sand, silt, and clay. Then when we add organic matter to it, we have loam. When we are talking about generality, the generality of the types of soil, we start from the stone, and their sizes can easily be noted because the changes in the size of this stone, of these soil particles, are in the range of 10. For example, if any particle size is greater or above 200 millimeter in size, then it is stone. If it's greater than 200 millimeter, that's bigger than 20 centimeters. Importance of soil texture. I said the soil texture supports the soil microorganisms. The microorganism lives within the soil texture. 2, soil texture determines the type of crops to grow. Depending on the type of soil texture you have, you can select the type of crops you are going to grow. But a very good soil texture that is smooth, that is not so big, then it will support the growth of most crops. It enables farmers to know the type of soil on his farmland. You know, a farmer will understand his farmland better. I will know what to do on the farmland once he knows the type of texture the soil is. Then it also helps the farmer to know the kind of tillage practices that will be done. Maybe we will make heaps or ridges, or we plant on the flat soil. The type of tillage activities that will be necessary, it will be revealed to the farmer once he understands the soil texture. And lastly, it determines the free movement of air and water. The texture that is loose, that is much of good grains and particles, will enable proper movement of air and water. Okay, now how can we determine the soil texture? Once you have a particular soil, how would you know maybe this soil is stone, or it is gravel, or it's fine gravel? How will you know what type of soil that you have? Well, there are about 4 methods to do this. The first one is called feeling by feeling. That's the sense of touch. You take the soil into the palm, you rub it between your palm, you rub it. Now, when we are dealing with this, it's good to analyze that we may have to be talking about agricultural soils. And don't forget, I say agricultural soils is between clay, silt, fine sand, and coarse sand. Now, when you feel with your hand, if it is very, very sharp and biting, rough, and coarse, that is clay and sandy soil. But when it is very fine, powdery, smooth, it is clay particles. But if it is in between, moderately, sharp, moderately smooth, that's silt. Then we can also test soil texture by mechanical analysis. Now, what by mechanical analysis? This has to do with the use of sieves. We use sieve through sieving. What do you mean by sieve? A sieve is like a bucket that has net underneath. The net is called sieve, is called mesh. The meshes have different sizes. Some are the meshes of some are very wide and large, while some meshes are very tiny. So the meshes are made in the ratio of 0.002 to 200 millimeter. That's how the meshes are made. This is a mesh. This is what we call a mesh. This is a mesh now. So this place could be maybe 2 millimeters. 2 millimeters. So now we have about 6 meshes from top here to this is 6 meshes. So this is a mesh. This is another 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 mesh. So these meshes are of different sizes. But this one will not be a mesh. This one will be sealed. So there's no mesh here. This is a mesh. Now, and this is a lid, a cover, lid or cover. These meshes, all these 1, 2, 3, 4, 5, 6, 7 containers can be fused together. You can press them together to become one. The soil to be analyzed, we put up here. Put the soil here, then you fix it together, you put the lid. You now hold it in your hand and toss it up. Shake it up and down, up, down, up, down. When you have done several like that, the soil you put in the upper container will pass through the mesh and fall through until it has gotten to this place. Now, why do we do that? Because the biggest mesh are on top. So this mesh now, the mesh size here will be 200 millimeter. The mesh here will be 20 millimeter. The mesh here will be 2. The mesh here will be 0.2. The mesh here will be 0.02. The mesh here will be 0.002 millimeter. While this one is no mesh or sealed. Now, at the end of the day, the big particles that are greater than 200 millimeter will stay here. That will account for stone. The one bigger than 20 millimeter will stay here. That will account for gravel. One that is bigger than 2 and like that until you get to this one. One that is less than 0.02 will fall in here, and that will account for clay particles. So this is a mechanical analysis of soil by sieving. Then we can also analyze soil by sedimentation. Mechanical analysis of soil by sedimentation. What we do is that we look for a glass jar that is transparent as glass. We now put the soil to analyze inside of it to maybe halfway. We now fill it with water to the brim. We cover the lid. Then we shake it. Don't forget, we put the soil to analyze the glass jar, transparent by the side. We put water, fill it to the brim. Then we shake it, that the water will disperse into the soil, and the soil will mix with water. We now put aside to rest for about 4 or 5 hours or overnight. When we now come back to the place, we see that the soil has rearranged itself based on their particle sizes in the glass jar. The one that is big will be under, the one that is fine will be above, and then there will be floating materials which we call organic matter on top. So this is the diagram illustrating it. This experiment will be conducted, and this is the inference, or this is the observation. So you find the glass jar, then the quartz sand is under because it's denser, it's bigger in particles. Then you have the fine sand followed, you have the silt followed, you have the clay particles in the water, then you have the clear water on top. Then on top of the clear water, suspended and floating will be the organic matter of the soil. This is the mechanical analysis of the determination of soil texture by sedimentation. The last one is by molding. That is, you take a sample of the soil into your hand, you put it with water, and you try to mold it. This one is used to test agricultural soils. Don't forget, agricultural soils are sandy, clay, then you can put loam if you put organic matter. So if you put water there, and then you roll it, if it is a sandy soil, it will be non-sticky. It will not be sticky, it will not coalesce together. There's no force of attraction between them. It will not be sticky. So you know it is a sandy soil. But if it is loamy, it will be sticky. And when you roll it, it forms weak ribbon. Then you know it is when you want to hold it, you want to pull it to break. That is loamy soil. If it is clay soil, it is very, very sticky, very, very sticky. It will bound together, and it can be shaped into different shapes, and it can be pulled. So it is sticky, it is cohesive, and it can be bent to shapes. That is moldy. So the 4 methods by which we can determine soil texture are by feeling, by mechanical analysis, through sieving, by sedimentation, and by molding.